Find the derivative of the function. There is no need to simplify your answer. The function of interest here is g of x equals secant squared of 3x. This is the same thing as writing secant of 3x, the entire thing squared. Looking at this function, you can see that we will need to be using the chain rule. We have an inside function which is secant 3x, and we have an outside function which is the exponent squared, the exponent 2 out here. Recall that the chain rule states if you're trying to take the derivative of a composition of functions, that is, if you have an inside and an outside function, then we will first take the derivative of the outside function and leave the inside function alone inside, and then we will multiply that by the derivative of the inside function. As previously stated, we have an inside function of secant 3x and an outside function of an exponent 2. So we can use the power rule to find the derivative of this exponent 2, and we will leave the inside function alone. So here, this g prime of x will look something like this. We'll bring that exponent 2 to the front. We have a secant 3x here, and we take 1 away from the exponent that was 2. We leave it as a 1. It's there, we don't write it, but that's exponent 1. And now we have to find the derivative of what's on the inside. So derivative of secant 3x. And again, there is a chain rule involved here. We have an outside function that is secant, and inside of our secant we have another function that is 3x. So we will have to do another chain rule on this portion of our function. So we have g prime of x. This portion still stays the same, 2 times secant 3x. The derivative of secant is secant tangent and we will leave the inside of that function alone. The derivative of what's on the inside of that function, 3x, the derivative of 3x is just 3. We do not need to simplify our answer, so our final answer is g prime of x equals 2 secant 3x times secant 3x tangent 3x times 3.